Hello again. We are going to answer a question, and that will be how to take a total differentials or total derivatives. Some people they call it, but the common name is total differentials, means that you totally differentiate a function. Now, as a definition, for a function of two or more independent variables, the total differential of a function is the sum over all of the independent variables of the partial derivative of the function with respect to variable times the total differential of that variable. In terms of example and definition, how you apply this definition, I'm going to show you a very easy way. It's very simple. If we have a function where function is z is equal to f of x and y, then if you totally differentiate this one, then you can write it that d, small change in z, is equal to partial derivative of this function f with respect to x. That's what it says. The independent variable of partial derivative of the independent variable times dx times the total differential of dx plus partial derivative of f with respect to y times the differential of that variable, which is variable y, that is dy. Now, by looking at this definition of total differentials, you probably see something similar that you see previously, and that is this term. This is delta f, or partial derivative of it with partial derivative of x with respect to x, is nothing but the rate of change in x direction times a small change in x plus the rate of change in y direction times small change in y. This whole writing, all this definition, implies that when you have a function of z, that is your dependent variable, and this x and y is your independent variable. If you totally differentiate this function, then the way you write it is you take the partial derivative of your argument with respect to first argument, holding the second one constant, times the total differential, which is the dx, and by dx we mean that the small change in x. So this whole thing here, you will see that this is a partial derivative over the rate of change in x direction times small change in x, and this is the partial or rate of change in y direction times small change in y. Let's do an example. So an example, let's say z is equal to x squared times y squared. So d of z is equal to, first we take the partial derivative of this function with respect to x. So 2x holding y constant, y to the power of 2, times total differential dx plus take partial derivative of this function with respect to y, hold x constant, times the total differential. So the partial derivative of this function with respect to y is 2x squared y dy. So that is when you totally differentiate this function of this equation. This is how you totally differentiate. Let us do another example, and that will be the last example. So example 4, let's say we have f of x and y is equal x to the power of 3, y to the power of 4, plus x squared, y cubed, plus 12. So if you have a problem like this, the easiest thing will be is always to write your function and then write the definition. And that is z is equal to f of x and y, and change in z is equal to partial derivative of this function f with respect to x times dx plus delta f with respect to y times dy. So write this one, and then now you try to find this. Now you take the partial derivative of this function with respect to x, holding y constant. So just write delta f over delta x, partial derivative of this function with respect to x is 3 x squared y to the power of 4 plus 2x y to the power of 3, and then the derivative, partial derivative of 12, it's a constant, that's 0. And also you take a partial derivative of, you find this, delta f over delta y. And that is you taking the derivative of this function with respect to y, holding x constant. Please stop the video and do take the derivative of this function with respect to y, and then come back with your answer and then compare it to mine. When you take the derivative of this with respect to y, then it becomes 4 x cubed y to the power of 3 plus 3 x squared y, 3 minus 1 is 2. So now you have the partial derivative with respect to x, and then also you have the partial derivative with respect to y. So now it's a matter of just plugging it over there. Then d of z is equal to delta f over delta x is 3 x squared y to the power of 4 plus 2 x y cubed delta x, don't forget, and plus delta f with delta y, that's 4 x cubed y to the power of 3 plus 3 x squared y squared delta y. So the total differentiation or total differential of this is equal to this one. I hope this will help, and it's very simple. Follow these steps. The steps are very simple. First, always write this definition. Once you write this definition, take a partial or partial derivative, like I did it here, and then you plug it at the end if you have something like this. But if you have one or two small variable and you have one term, then you don't have to do this. You can just totally differentiate the function. Again, stay tuned for other videos.